number 11, we have two functions, and we have, looks like 12 parts altogether because there's 11 remaining. So we're going to be completing parts A through H, and for parts A through D, we're also going to find the domain. So remember, domain, we're looking for fraction, square root, and logarithm. If we see those, we have restrictions. Otherwise, domain is all real. All right, so number 11, we are given f of x equals, and that is x minus 6. And then we have another function, g of x, which is 5x squared. All right. And this first part, A, says f plus g of x. So this is not a notation to mean multiply f and g times x or distribute it. But this is just saying we want you to take the f equation, f of x equation, and we want to add it to the g of x equation. So we're just going to be adding these two. That plus sign is telling you what you need to do. So the f equation is x minus 6. The g equation is just 5x squared, so I'm going to add it. You do it in that order, 5x squared. And you can rearrange this and put it in standard form, which means put in the largest exponent up front. But even if you left it like this, this will be totally fine. We just want you to get the concept. But standard form, which is even better, okay, is just putting it in order from largest exponent to smallest. So it'll be positive 5x squared out front, plus x because that's positive, and then minus 6. So either one of these would be fine. The second one is better. Okay, but I'm going to insert it like this just so you can see what's going on. So we have x minus 6 plus 5x squared. Okay. And if you type it like this, it's better, but it's okay. And then what is the domain for this guy? Well, there's no fraction, there's no square root, there's no log, so my domain is any real number. Alright, so now we want to subtract f and g. So part B, we're going to do f minus g of x. And this will give us x minus 6, the f part first, and then minus the g part, minus 5x squared. So again, I'm just going to leave it like that. If you want to rearrange it, it would be better if you put the 5x squared out front. It is negative, so you have a negative 5x squared, and then a positive x, and then a minus 6. That's even better if you can do it that way. But this is fine, okay? I'm going to put it in the order that it is received. And so that's going to give us x minus 6 minus 5x squared. And what is the domain of this function? So again, we do not have any fractions, no square roots, no logarithms, so all real. Alright, part C, this time we want to multiply f and g. This is f times g of x. So we have f times g of x. So that means we're going to take the f equation, which is x minus 6, and we're going to multiply that times the g, which is 5x squared. So I've got to distribute here. So x times 5x squared will give me 5x cubed. And then negative 6 times 5x squared will give me a negative 30. Negative 5 and 6 give me a negative 30x squared. And this is all we can do here. So we get 5x cubed. 5x cubed minus 30x squared. Alright, and now domain here. So again, domain, you look for fraction, square root, and logarithm. Neither of those are present here, so our domain is all real. And then now we actually have to divide the two. So f divided by g of x. So f divided by g of x. So we put the f equation on top, x minus 6. On the bottom we put the g, which is 5x squared. And that's all we can do. Can't simplify anything here. Let's go ahead and do the domain. So this time we do have a fraction, so we take whatever's on the bottom and we set it equal to x squared, or not equal to 0. And then we solve. So 5x squared not equal to 0, solve for x. We would divide by 5 first, leaving me with x squared is not equal to 0, because 0 divided by any number is 0. And then we take the square root, and you got plus or minus, but 0 is neutral, so you just have x cannot be equal to 0. Yeah, that should be good to go. Alright, so let's insert this fraction, x minus 6 on top, 5x squared on the bottom. Our domain this time has restrictions. X cannot be 0. So we're going to say x cannot be equal to 0. Okay, so now this is a different notation here. This means we're going to add the two equations up, but we're going to plug a 3 in for x. So there's one of two ways you can do this. You've already added these two equations up at the top. And we had this equation. All we have to do is plug a 3 in here, or we can just do it separately and then add the two numbers. Generally, I'll recommend you do it separately, so that's what I'm going to do. So you have, let me show you what this means. We have f plus g of 3. And what this means is you take the f equation, you plug a 3 in, and then you add that to the g equation when you plug a 3 in. Alright, so I'm going to work down. So f of 3 is going to be x minus 6, or 3 for the x minus 6. And then the g equation over here, we had 5x squared, or 5 times 3 squared. So just plug it in each one of them. We solve this. This gives us a negative 3 plus 3 squared is 9, and 9 times 5 is 45. So negative 3 plus 45 equals positive 42. So f plus g of 3 gives us a positive 42. Alright, so now we're going to subtract the 2 by plugging in the number 4. So f minus g of 4. What that means is f of 4 minus g of 4. So you plug in a 4 for your x's. 4 minus 6 minus 5, 4 squared. I put it in parentheses in case there were more than one term on the g. You would have to change all the signs. So you got to be careful with that. So 4 minus 6 gives me a negative 2. Minus 16 times 5 is 80, so minus 80. And this gives us a negative 82. We're going to multiply with 2n now. So we have f times g of 2. So that is f of 2 times g of 2. Alright, so f of 2 would be 2 minus 6. I'm going to multiply that by 5 times 2 squared. Alright, 2 minus 6 is negative 4. So we get a negative 4 on this side. 2 squared is 4 times 5 is 20. Negative 4 times 20 gives us a negative 80. So that would be our final answer, negative 80. And then f divided by g of 4. So what that means is we're going to take the f equation, plug in a 4, take the g equation, and plug in a 4. Now, we did use 4 already up here when we subtracted. We plugged in a 4 for f and we got negative 2. We plugged in a 4 for g and we got 80. So we have a negative 2 over 80. We can go and plug it in again, but since we already used it, let's just use what we already have. So negative 2 divided by 80, and then we would divide both of these by 2, so that would give us a negative 1 over 40. And that would be our simplified answer, negative 1 over 40.